What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about virtualization and network storage technologies such as virtual switches, virtual firewalls, virtual NICs, virtual routers, hypervisors, network attached storage area networks, fiber channel over Ethernet, Fibre Channel, iSCSI, InfiniBand, and jumbo frames. Let's talk about virtual networking components. So the first one is a virtual switch. So a virtual switch, this is a software application that allows communication between virtual machines. A virtual switch does more than just forward data packets. It intelligently directs the communication on the network by checking data packets before moving them to a destination. Virtual switches are usually embedded into installed software, but they may also be included in a server's hardware as part of its firmware. A virtual switch is completely virtual and can connect to a network interface card. The virtual switch merges physical switches into a single logical switch. This helps to increase bandwidth and create an active mesh between servers and switches. Let's talk about a virtual firewall, and this is a network firewall service or appliance running entirely within a virtualized environment and which provides the usual packet filtering and monitoring provided via a physical network firewall. The virtual firewall can be realized as a traditional software firewall on a guest virtual machine already running, or a purpose-built virtual security appliance designed with virtual network security in mind, or a virtual switch with additional security capabilities, or a managed kernel process running within the host hypervisor. Next, we have a virtual NIC. So a virtual NIC uses the host physical network adapter to initiate and manage network communications. It is created by the operating system or a purpose-built software application. Once created, it can be used for different applications and networking services. So for instance, a virtual NIC enables a computer to connect to a VPN while being simultaneously connected to another network. Each of the virtual NICs is considered a unique device, and each has its own separate IP address and network configuration. In virtualization environments, each virtual machine is generally installed with a virtual network adapter for communication between other virtual machines or with the network itself. Let's talk about a virtual router. So this is a software function that replicates in software the functionality of a hardware-based layer 3 internet protocol router, which has traditionally used a dedicated hardware device. Virtual routing is a form of network functions virtualization in which the functions of traditional hardware-based network appliances are converted to software that can be run on standard commercial off-the-shelf hardware. This has the advantages of lowering hardware costs and allowing more hardware interoperability rather than requiring a proprietary hardware platform. Let's talk about a hypervisor. So a hypervisor, also known as a virtual machine monitor. This is a computer software, firmware, or hardware that creates and runs virtual machines. A computer on which a hypervisor runs one or more virtual machines is called a host machine, and each machine is called a guest machine. A virtual machine is a software emulation of the hardware in a working computer. The VMM sets up emulated motherboard chipsets, USB controllers, hard disk host adapters, video cards, and other components of an actual computer as part of the virtual machine, along with setting aside either an expandable or fixed amount of hard disk space. After a hypervisor creates and configures a virtual machine, you install the operating system and apps desired into the virtual machine to have a working emulated computer or virtual machine. The hypervisor is used to start the virtual machine, and depending on the RAM, processor speed, and features, and available hard disk space in the physical computer, the hypervisor can run several virtual machines at the same time. Now, there are two types of hypervisors. The first one is called a Type 1 hypervisor, and this is a virtual machine monitor that works directly with the host computer hardware rather than being installed inside of an existing operating system. And Type 1 hypervisors are often referred to as bare metal hypervisors. You have a Type 2 hypervisor, and this is a virtual machine monitor that runs inside of an operating system and carves out RAM RAM and disk space for an already running system. So the main difference between the type 1 and type 2 is as follows. Type 1, you turn on the machine and it automatically boots into the hypervisor, so you can go about the process of creating the VMs. Type 2, you turn on your computer, it loads your normal operating system, then you have to load the hypervisor or the virtual machine software, which will then allow for you to create the virtual machines. Let's talk about network storage types. So the first one is NAS, or network attached storage. So a network attached storage system, this is a storage device connected to a network that allows storage and retrieval of data from a centralized location for authorized network users and clients. Network attached storage is a self-contained storage device that contains one or more drives, a network interface, and is bundled with software to enable computers on the network to access the device. A network attached storage device built for use in business may have 2 or more drive bays, permit easy upgrading of drives, and might also provide automatic mirroring, known as copying, of the contents of one drive to another, and that is also known as RAID 1. Then we have a storage area network, and these are sometimes referred to as networks behind the servers and historically developed out of a centralized data storage model, but with its own data network. A storage area network is, at its simplest, a dedicated network for data storage. In addition to storing data, storage area networks allow for the automatic backup of data and the monitoring of the storage, as well as the backup process. A storage area network is a combination of hardware and software. Storage area networks are primarily used to access data storage devices such as disk arrays and tape libraries from servers, so that the devices appear to the operating system as direct attached storage. A storage area network typically is a dedicated network of storage devices not accessible through the LAN. Although a storage area network provides only block level access, file systems built on top of a storage area network do provide file level access and are known as shared disk file systems. Next, let's talk about connection types. And the first one is Fibre Channel over Ethernet. Yes, it is pronounced fiber, even though it is spelled F-I-B-R-E. For some reason, they decided to spell it F-I-B-R-E instead of F-I-B-E-R, but they are the same word. So Fibre Channel over Ethernet, this is a computer network technology that encapsulates fiber channel frames over Ethernet networks. This allows fiber channels to use 10 gigabit Ethernet networks or higher speeds while preserving the fiber channel protocol. Also, fiber channel is designed as a channel interface. That is, it guarantees lossless delivery of frames with a predictable latency. Since classical Ethernet had no priority-based flow control, unlike fiber channel over Ethernet required enhancements to the Ethernet standard to support a priority-based flow control mechanism to reduce frame loss from congestion. And then let's talk about fiber channel. So this is a high-speed data transfer protocol providing in-order, lossless delivery of raw block data. Fiber channel is primarily used to connect computer data storage to servers and storage area networks in commercial data centers. Fiber channel networks form a switch fabric because the switches in a network operate in unison as one big switch. Fiber channel typically runs on optical fiber cables within and between data centers, but can also run on copper cabling. Supported data rates include 1, 2, 4, 8, 16, 32, 64, and 128 gigabits per second, resulting from improvements in successive technology generations. Then we have iSCSI, or Internet Small Computer Systems Interface. So in computing, iSCSI is an IP-based storage networking standard for linking data storage facilities. It provides block-level access to storage devices by carrying SCSI commands over a TCP/IP network. iSCSI is used to facilitate data transfers over intranets and to manage storage over long distances. It can be used to transmit data over LANs, WANs, or the internet, and can enable location-independent data storage and retrieval. The protocol allows clients, which are called initiators, to send SCSI commands to storage devices, which are called targets, on remote servers. It is a storage area network protocol, allowing organizations to consolidate storage into storage arrays while providing clients, such as database and web servers, with the illusion of locally attached SCSI disks. It mainly competes with Fibre Channel, but unlike traditional Fibre Channel, which usually requires dedicated cabling, iSCSI can be run over long distances using existing network infrastructure. Then we have have InfiniBand. So InfiniBand, this is a computer networking communication standard used in high performance computing that features very high throughput and very low latency. It is used for data interconnect both among and within computers. InfiniBand is also used as either a direct or switch interconnect between servers and storage systems, as well as an interconnect between storage systems. It is designed to be scalable and uses a switched fabric network topology. InfiniBand offers throughput of up to 2.5 gigabytes per second and support for up to 64,000 addressable devices. Because it is also scalable and supports quality of service and failover, InfiniBand is often used as a server connection in high performance computing environments. And then we have a jumbo frame. So in computer networking, jumbo frames are Ethernet frames with more than 1,500 bytes of payload. Commonly, jumbo frames can carry up to 9,000 bytes of payload, but smaller and larger variations do exist. Many gigabit Ethernet network interface controllers and some fast Ethernet switches and fast Ethernet network interface cards can support jumbo frames. Each Ethernet frame must be processed as it passes through the network. Processing the contents of a single large frame is preferable to processing the same content broken up into smaller frames, and this makes better use of available CPU time by reducing interruptions. This also minimizes the overhead byte count and reduces the number of frames needed to be processed. This is analogous to physically mailing a packet of papers instead of several single envelopes with one sheet each, saving envelopes and cutting sorting times. All right, so that is my quick little class on virtualization and network storage technologies, where we talked about all of this wonderful stuff, such as virtual switches, virtual firewalls, virtual NICs, virtual routers, hypervisors, network attached storage, storage area networks, fiber channel over Ethernet, fiber channel, iSCSI, InfiniBand, and jumbo frames. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.